Okay, so our notes today are just going to be a review. So these are all things that I can literally ask you to pull up in your spiral and you should have. So I'm not going to go through every single question on here, but I will go through some, and we're going to kind of go through as many of these questions as we can just to give you a good idea of what you've already seen before. Okay, so in the top part up here, it says to review how to evaluate a function. So the directions specifically say to substitute the given expression into the function and simplify. Keep in mind everything that's in the parentheses, so everything in here that's in your parentheses is going to be plugged in for x, into this x, and this x. So anytime you have function notation, whatever variable or number is in the parentheses, for instance here, you're going to substitute into your original equation for x. So for f of negative 4, we're going to plug that in to x squared minus 2x. Instead of putting an x, though, we're going to substitute that negative 4 into both of those parentheses. So negative 4 here, negative 4 here. Let me actually do that in a different color so you can see it. So let's make this negative 4, negative 4. And I'll try to use different colors when I substitute things in. So from here, we're just going to simplify. So Mia, what's negative 4 squared? And then negative 2 times negative 4? And what is 16 plus 8? That should be your answer. For letter D, we're going to do the same thing. So for letter D over here, we're going to do the same thing. All of this is supposed to be plugged in for x. Even though I already know, yes, I can see that there's an x here, but this is an expression. There are two terms, the x and the plus 3. We're going to take that entire x plus 3, and we're going to replace it for both of the x's. So we're going to make this x squared minus 2x. In that parentheses, we're going to put in x plus 3, x plus 3. Chris, what does it mean when you have something like this that's being squared? Multiply it by itself. So make sure that you rewrite this as x plus 3 times x plus 3 minus 2 times x plus 3. Obviously, since you're going to multiply it by itself, you're going to need to FOIL, so we're going to distribute. So we're going to make this x squared plus 3x, 3x plus 9. And then I can distribute this negative 2 to both of these terms. So I'm distributing the whole negative 2 to make this negative 2x minus 6. It looks like a lot, but we're just going to combine everything that we can. So the x squared is just going to stay in x squared. That's going to stay as it is. I can combine the both of the 3x's and the negative 2x. So 3 plus 3 is 6. 6 minus 2 is going to give me 4x. And then 9 minus 6 is positive 3. That would be your answer. So far, so good? Okay, let's look at the next section. Okay, the next section says review function operations. So given the three functions, f of x, g of x, and h of x, perform the indicated operation for each problem and then find the domain. So guys, there's also a separate note here. I'm highlighting it in green. Find the domain. We talked about how to find domain restrictions, so that's what you're going to be needing to refer back to in case you forgot. So let's start by looking at the first example. It has f plus g parentheses x. Okay, so Maria, looking at question 1, what is this asking you to do? Okay, so which two am I adding? Perfect. F of x plus g of x. You're adding both of those. So guys, make sure you write that out to show what you're actually adding, so when you're doing this on your tests and quizzes, you know. Okay, so the f of x function is x squared minus 8x plus 4. You can put that in parentheses. It's not going to hurt your answer. Plus g of x, which is 4x minus 3. I usually suggest my students plug things in using parentheses so you don't make a mistake. From here, Maria, is there anything I need to distribute at all? No, there's nothing I need to distribute. So I can drop the parentheses. And then combine your like terms. Okay, well the x squared again is just x squared. Negative 8 plus 2 is going to give me negative 4x. And then 4 minus 3 is positive 1. That would be your answer. So before I actually box that, hold on, before you box it, this is technically for f plus g, for the composition, or not composition, but the polynomial operation of f plus g of x. The last thing that it asks you to do, guys, is to find the domain for this. Okay, so I'm coming back to you, Maria. For the domain for this, what type of function is this? It's a quadratic function. So we literally just spent a bunch of time graphing quadratic functions. We know that it's going to have a max or a min, and it's going to open up or down. Looking at the a value that's in front of the x squared, is this graph going to open up or down? Up. So I don't know exactly what it's going to look like, but it's going to probably look something like this. When it asks you for the domain, guys, think of what function and what the graph would look like before you start identifying the domain. So Maria, based on the graph that I just made, what's the domain going to be for that? And what's another way to write that? That's exactly it. So you can either write it as all real numbers or from negative infinity to positive. So that's all I'm asking you guys to do. So I'm going to give you guys a little bit of a head start. For questions 3, 4, and 5, I want you to try to start those off without me. So for questions 3, 4, and 5 on this page, I want you to try to start them off without me. Before you start off question 3, though, what does this mean, this little dot in the middle? Multiply. It doesn't mean composition. It means to multiply. So for this question, you are just multiplying out f of x times g of x. This is not a composition. I will say that again. Not a composition. All right, I'm going to give you guys a couple minutes. Go ahead and get started and see if you can finish questions 3, 4, and hopefully number 5. All right, so looking at question number 3, we should have taken f of x, which is x squared minus 8x plus 4, and we're going to multiply it by g of x, which is 4x minus 3. I will say this again. This little dot, the closed dot, does not represent a composition. This is just multiplication, guys. So just multiplication, not a composition. So when you're doing that, you're just going to distribute. You're just going to FOIL this out. So for this question, I'm going to go ahead and FOIL. X squared times 4x is going to be 4x to the third. X squared times negative 3 is going to give me negative 3x squared. 8 times 4 is negative 24x squared. Be careful there. You should have had an x squared. Negative 8 times 3 is positive. Whoa. Let me try that again. Negative 32x squared, because 8 times 4 is 32, right? And then 8 times 3 is 24. Okay, good. Double check my math, guys. Make sure it looks good. And then 4 times 4 is 16x. And then 4 times negative 3 is negative 12. So double check my numbers. Make sure my signs and my numbers look good, guys. All right, once we have that, I'm going to get my little pink pen and I'm going to combine my like terms. Okay, there's nothing to combine there. This and this, I can just add both of those to make that negative 35x squared. I'm going to combine both of these to give me positive 40x and then minus 12 at the end. So f times g of x is what we just found. And this is a 4x cubed, not squared, cubed. Look at my stuff, make sure it matches yours, double check it. What type of function is this? We haven't talked about it yet, but what does it mean when it has an exponent of 3? Not cube root, just cubic, just cubic. Cubic is where you have x to the third power. So with the cubic function, we haven't talked about it yet, but we will. Cubic functions are going to look something like this. So something like this. So if I was to ask you for the domain for this, Enya, what would the domain be for this graph? Negative infinity to positive infinity, yep. Or you could write it as all real numbers. Perfect. Let's look at example 4. Make sure I'm not making mistakes, guys. If you see some numbers that don't look right, let me know as soon as you see it. All right, for example 4, this one's asking you to divide. Okay, so let me write this out, what you should have done. F of x divided by h of x. Okay, let me recopy f of x and h of x. I could put parentheses around these guys, but there's nothing that I can distribute or try to multiply it by, so I don't really need the parentheses, so I didn't write them. Elizabeth, let me ask you this. Can I simplify this at all? When I ask to simplify, I know usually I would try to cancel something out since it's a fraction. This is a trinomial. Is there any way I could maybe simplify this polynomial into 2 binomials? Can I factor this? Let's see. If I was to try to multiply this, I would need to find 2 numbers that multiply to 4, right? And add up to -8? What do you mean, no? Is there 2 numbers that multiply to 4 but add up to 8? Yes or no? Because the only multiples we have, right, are just 1 and 4 and 2 and 2. Those are the only multiples. I don't want to deal with fractions. So can any of those numbers add up to 8? No. Okay, so for this one, we cannot factor. Since we can't factor, if we were able to, let me kind of take a step back for a second. If we were able to factor, look up for a second, we would have had something like x plus 2 and x plus 4. If we could have factored it, we could have canceled out this denominator. But since we don't have something that can cancel and we can't factor it, we have to leave it like this. My question to you is, because right now we have our answer, which is f divided by h of x is equal to that fraction. Elizabeth, what would be the domain for that? What should I do? I'll give you a hint. When you were back in the very first semester, very first cycle, we had a page that looked just like this. Elizabeth, read that first thing for fractions. What does it say? Not just that it's not equal to 0. Read this part up here. What does that say? Your denominator cannot equal 0. The reason why, for like this first question, 1 over 0, what is 1 over 0? It's not 0. Use your calculator. It's undefined. It gives you that error message. That's why I'm telling you guys, whenever you have a fraction, you want to avoid having any zeros in your denominator. So looking back at the notes that we have here, what should I probably do with that denominator, Elizabeth? Make it not equal to 0. So we're going to take x plus 2 equal to 0, and we're going to put a little slash through it. I do not want my denominator to equal 0. So by solving this equation, by subtracting 2, I'm telling you where your denominator you do not want to equal to 0. If your denominator is equal to 2, so if your denominator was equal to -2 specifically, and you plugged it in here, what's -2 plus 2? 0. So you would have some number, I'm just making this up, 4 over 0, which is that error message, which is undefined. So that's a number that you want to avoid having in your domain. You can use any other number except for -2. So how would I write my domain for that? Go ahead, Elizabeth. How would I write it? I can use any number except -2. I'll give you a hint. We did this at the very beginning of the school year. For instance, when it wasn't equal to 0, when we didn't want 0 in our denominator, we wrote it from -infinity to 0, and then from 0 to infinity. How would I write it for this question, though? That's it. When you guys are solving this, make sure that you actually put that domain restriction. You cannot have your denominator equal to 0. So in order to avoid that, you avoid using -2 altogether. We're going to skip over -2, get very close. You can get -1.9, -1, or -1.98, all those. You just don't want it to equal actually -2. All right, last one we're going to look at is question number 5. This one is a composition. So this one does represent a composition. It should be probably written as h composed with g of x. So it should look like this, but they've already kind of written out our composition form. So we can rewrite this as h of g of x. Okay, with that in mind, let me go ahead and simplify. So we're going to work from the inside out. And I will keep saying this all day. We're going to work from the inside out. So we're going to start with g of x. Okay, let me look back at the top of my page. G of x is 4x minus 3. I always ask my students, double check in the parentheses. Is there anything we can simplify here? No, there's nothing. It's just a 4, an x, and a 3. Can't combine anything. Next, we're going to actually do the h part. So the h part is using the h function x plus 2. In that parentheses for x, I'm going to replace it with that 4x minus 3. Omar, what would I do from here? Is there anything to distribute? No. So what could I do with the parentheses? And now what? And what is negative 3 plus 2? So h of g of x is equal to 4x minus 1. There's one last thing that it asked you to determine in the directions, and that's the domain. So if you were to actually graph this out, Omar, what would 4x minus 1 look like? What shape would it make? Okay, so it's in slope-intercept form, so you would start on the y-axis at what point? Okay, so here's negative 1. We're going to plot that point. Then where would you go? Okay, so it's going to have a slope that looks something like this. That's your graph. It begins with the L. What type of function is that? Linear. Thank you, Caitlin. It's a linear function. So, Omar, go ahead and tell me, what's the domain for a linear function? Read that graph from left to right. What's the domain? All real numbers. Yep. Negative infinity to positive. All real numbers. Guys, it's not just taking function composition and writing it out. I know you guys can do that, but I want you to relate it now to your domain. If you were to graph this out as a function, what would that look like? Questions, concerns, fears? All right, perfect. Flip it over to the next page really quick. All right, let me explain what you're doing on the next page. Keyword, what you are doing on the next page. All right, with my orange pen, I'm going to highlight a few questions that I want you and the person next to you to try first before I go through them with you. I want you to do number 7. I'll give you a hint. H and F are on the first page that we just flipped from. I want you to try question 10, question 11, and questions 13 and 14. So I'm going to zoom out so you can see all of them. Try to do each one of those. I'm going to give you about 3 minutes. See if you can get all of those done. All right, so let's look at question number 7. First, Tristan, what did you get for question number 7? What was the answer? Negative 16? I'm just making sure I heard you right. Okay, let's double check. So we're going to make this, what did you do to get negative 16? Okay, and what did you plug in for h? 3 for the x's in the h function. And we're going to subtract that from f of 3. Okay, the next thing you should have done was use the h function, which is x plus 2, and you're going to plug in that 3. So x plus 2. In that parentheses, we're going to plug in the 3. We're going to subtract it from f of 3. Be careful here, guys. You're subtracting whatever value you get, whatever solution you have for f of 3. So what I would suggest doing, I'm going to box this out. I would recommend putting this in a bracket. So that way you can actually write this out. So what I'm going to do is put a big bracket around your parentheses, or around your subtraction sign for f, and I'm going to plug this in. We're going to make this x squared minus 8x plus 4, because there might be a mistake for some people. In the parentheses for x, we're going to substitute in a 3. What I would recommend doing, guys, is using PEMDAS to simplify. So we're just using order of operations. When I say PEMDAS, guys, I'm purposely really talking about this second half of the problem because you have a lot of things that you're adding, subtracting, multiplying, all that stuff. So what I'm going to do from here is I'm just going to keep the parentheses, 3 plus 2 minus. That first thing I notice is you have a 3 squared. So I'm going to deal with that 3 squared to make it 9. I've done the parentheses. I'm working on the parentheses. I've done the exponent. M and D means to multiply and divide. We're going to make this 9 minus 24 plus 4. And from here, we're going to continue to simplify. So with the multiplying and dividing, I'm pretty much done with that. I just need to add and subtract. So we're going to have 3 plus 2 minus. In that parentheses, Tristan, what's 9 minus 24?
13.
Try it again. Help them out, guys. Negative 15. Thank you. And then plus 4. What's negative 15 plus 4, Tristan? Negative who? What's 15 minus? Negative 11. Let's get you a calculator. All right, so what operation are we going to do with both of those negatives, Tristan? Make it positive. Okay. So you guys help them out. What's 3 plus 2? 5. And then 5 plus 11? 16. What kind of 16? Positive. So there should be a positive 16, guys. Tristan, is that okay? All right. All right, let's look at the next question. Be careful with those, guys. It's not just a sign, but make sure that you actually know how to add and subtract your numbers. All right, for question number 10. Chizara, what does it mean when you have this? What does this mean? Okay, so how would you write this out in function notation? Because right now it's a function composition. So I'm going to write this as g of 16, because whatever answer you get for g of 16 on the inside, you're going to use that answer to find the next g, whatever that is. So whenever you see these little bubbles, guys, these are compositions. So make sure you write those as actual compositions. And I think it even says that in the directions. Each of these are a composition. All right, so let me go back to what you were saying. Okay, you were saying to do the G table, right? Okay, so your G table is here. You're going to work again from the inside out. So start with G of 16. What is the value for G of 16? 4. So over here, I'm going to make this G of 4 because at 16 for x, because remember, these are your x values. At 16 for x, your value is going to be 4. Are you done? What else do you still have to do? Okay, so now you're going to find G of 4. So in this table, what's G of 4? So here's your 4. That's for x. Your value is just going to be 2. Once I find that 2, Chisara, do I need to do G of 2 or just do 2? Just 2. That's your answer. Good job. Guys, it's not that difficult. Don't make it more difficult than what it needs to be. For the next one here, I'm going to rewrite this first. You're doing G of F of 4. You're doing a composition. So for this question, make sure you look at your table before you start writing down your answers. Caitlin, to find F of 4, because that's the innermost parentheses, F of 4, you're going to use this table over here for the function F. On this table, what's F of 4? 1. Okay, so over here, I'm going to go back to my little value, and I'm going to put G of 1. That's what Caitlin just told me. Now what are you going to do, Caitlin, for G of 1?
You're going to look at the table and...
Which table?
G of x.
Okay, so this table. And what is G of 1?
1.
G of 1 is just 1. So it ironically is the exact same number. It won't always happen that way, but for this one it does. Guys, that's all you're doing. It's not too crazy. For the graphs, though, make sure that you pay attention to what graphs you have. Yours aren't in color on your paper, but they are in color on mine, so you can see exactly what you're doing. I'm going to use the space next to it to do question 13, which is H of F of 3. All right, so the first thing I need to do is find F of 3 on my table. If I was to look at F of 3, that's the blue graph. 3 on the x-axis is going to show -4 on the f graph. So over here for h of f of 3, we first found h of negative 4, because at f of 3 we got negative 4. And now we're going to use the h function, which is the quadratic parabola that's opening up. Here's negative 4, and here's my point. Your point on the h of x graph is going to be right here at 5. That should be your answer. For question 14, same thing. This one we're going to do h of g of 4. So, Emma, what's g of 4 on this graph? Positive 2, right here. Okay, perfect. So now I'm going to do f of 2. So look on the graph, Emma, what's f of 2? Negative 3, right here. Give me some nods or shakes. Does that refresh your memory? Perfect. Let's look on the next page. All of the rest of them, if you want to have fun doing them, have fun. We, however, are going to move on to the next page. All right, we're going to look at questions 18 and 20. I'm going to do question 18 with you guys. You will try number 20 in just a second. So for question 18, let's look at this. It specifically says evaluate your compositions and then indicate the domain. All right, so let's look at part A for question 18. First thing I need to do is find g of f of x. Okay, so let's find g of f of x. G of f of x is this guy here. So it's the square root of x minus 3. Andrea, can I do anything to that square root of x minus 3 in the parentheses? No. Okay, cool. Just take a second to look at it. When that happens, move on. Okay, now we need to take all of this and substitute it in for the g function. Okay, well, here's your g function. Instead of using x, we're going to plug in the x or square root of x minus 3. So we're going to rewrite this as parentheses squared plus 3. I'm going to replace that with the square root of x minus 3. Andrea, what can I do here to simplify? Why? They cancel each other out. They're inverses of each other, so you can cancel those. So we're going to leave that with x minus 3 without the radical, plus 3 at the end. What can you do now? And what is negative 3 plus positive 3? 0. It cancels. So you're just left with x. What's the domain for just x? What type of line would you have? Like a straight one. Straight up and down, like slanted. Where would it go? Slanted. This is just the linear parent function, guys. It's going to go through the origin, and it has a slope of 1. So it's just a linear parent function. So think of the graph, and then, Andrea, tell me what's the domain. Yep. We're doing the same thing for the part next to it. For the part next to it, we're doing the same exact function, using the same exact function. We're just using it in kind of a different order in a way. So over here to the side, I'm going to move this over. And we're now going to do the function composition of f of g of x. All right, so first things first, let's find out what g of x is. Let me look back. G of x is x squared plus 3. Lorraine, can I simplify anything in that parentheses, any of the x squared plus 3? No. Okay, just take a second to look at it, make sure nothing cancels. Once we do that, we're going to now plug this in for the f function, which is the square root of x minus 3. So I'm going to rewrite the square root of x minus 3. In that parentheses, I'm going to write x squared plus 3. Be careful with this, guys. Make sure that you're just not canceling things just for the sake of canceling. First thing you should definitely do is remove the parentheses. So I'm going to rewrite this as the square root of x squared plus 3 minus 3. Lorraine, what should you do now? Yep. Guys, before I finish this up, make sure you listen to what she said. She said cancel the 3 and negative 3 first. The reason why is because this square root of x squared, you cannot cancel it unless it's left to something like this, where it's just the square root and the x squared. On the last question, we didn't have that issue because all of this, the x and the 3, were all under the radical. That's why we were able to cancel both of those. So just be careful. So down here, I'm going to simplify this to just x. And luckily, the domain for this that Andrea told me before, if I could spell domain correctly. That's how you spell domain, right? Okay, good. I've been seeing it all day today. Is all real numbers. There's something that I want to kind of refresh your memory on. When you have, and you don't have to highlight this, when you have function compositions that simplify to x, what does that mean? Maria? Oh, I'm so proud of you. If I had a gold star, I'd give it to you. They're inverses of each other. We learned this, guys, literally first cycle. So when you have, if you look at your paper that's right in front of you, f of g of x equal to x, we just found that, and g of f of x equal to x, those are inverses of each other. So just make sure, guys, whenever you're simplifying them, relate it back to what we've already done. I'm probably not going to test you guys on that this semester, but you already saw it first semester, so you might as well remember it. When you get into pre-cal, guys, fair warning, we're going to review this again, so make sure you know it. All right, I'm going to give you guys about a 2-minute head start. Try to do question 20. You have a brain, you have somebody next to you. Try to do question 20. All right, guys, let's think for a second. Let's hear what you guys are thinking, or if you weren't thinking about it, let's think about it together. So it says a video game store adds a 25% markup on each game that it sells, and it can be represented by the function m of x equals 1.25x. The store also pays $1.50 in shipping charges for each game. That can be represented by the function s of x equals x plus 150. Let x equal the manufacturer's cost of the video game. So part A represents write the composition or composite function to find the final or to find the cost of the video game if the markup is applied after the shipping is added. Okay, so I purposely underlined after and I purposely wrote it in this form. What you need to do first, if you haven't already, is you need to write this in its composite form. So you need to have something of x, because the variable in this problem is x for the s of x and the m of x. Remember, whatever goes on here happens first. Whatever goes on here happens second. So you guys need to tell me, what's happening first? Are we getting charged for the shipping first or the markup? Which one is happening first? The shipping happens first because it specifically says, let me go back up and highlight it. Stop talking and listen. If the markup is applied after the shipping, after means it's going to be second. So the first thing that's happening is the shipping. The second thing that's happening is the markup. So I'm going to put in this parentheses, the first is the shipping and then the markup. This is what you're solving. So we need to find the composition of m of s of x because it specifically said write the composite function. So that first part that's not in view on the screen, write the composite function. It needs you to write an equation for it. So first thing I'm going to do is plug in the s of x, which is the shipping. This is x plus 150. Desiree, can I add anything with that x plus 150? Can I combine that? No. Okay, so let's take that and use the m function now, which is 1.25 times x, which I'm going to plug in instead as x plus 150. Desiree, what can you do from here? Okay, get your calculator ready. I know I'm going to have to distribute. This is 1.25x. Desiree, what's 1.25 times 1.5? Yep. And this is going to be for m composed with s of x. If I could actually write an x. That would be your answer. Give me a nod or shake. Do you understand how I wrote that out? On your tests and quizzes, guys, if you write this out, take a second to just think. If you read what I give you, I will tell you how I want it set up. I specifically told you your markup is applied after the shipping. If it's after the shipping, that means the shipping has to go first. All All right, last part is what is the cost of your video game at the store if the manufacturer's cost of the video game was $13? Where are you going to plug in that 13? Since it specifically says X is the manufacturer's cost for the game, congratulations, you're plugging it in for X. All of this could be represented as a big Y. I don't want it as a big Y right now. I want you to rewrite all of this, the X. I want you to plug it in for X, both of these. So let me show you guys how I want it plugged in. So you're doing the composition of M composed with S of X, which is 13. That's the cost of the manufactured game. We're going to plug it in as 1.25 times 13 plus 1.875. What this tells me is that you are finding the specific value for the cost at the store when the manufacturer only charged $13. That's what this means. You have a brain, you have a calculator, use it. So if I was to multiply 1.25 times 13, I'd get 16.25. And then what's 16.25 plus 1.875? Okay, let's round it to 2 decimal places. So 18 point what? 18.13. That would be the cost of the store. So the store would charge you $18.13. All right, there's one last question that I want you guys to try to start and complete in the next couple minutes. So far, does all of this stuff kind of refresh your memory a bit? Perfect. All right, last page, which is this guy here. I want you to do, because y'all know I'm the way I am, do question 24. Have fun. I'll give you guys a major hint. Do not try to multiply the entire expression. This is an expression, not an equation. So you can't just get rid of those denominators. You have to deal with them. And then secondly, if you get a final answer that's like X equals some number, you've messed up completely. Do you see an equal sign right now for 24? No, you do not. So don't put it equal to anything. Okay, let's see what you guys should have gotten. Okay, so the first thing that I did was take it one step at a time. I just dropped the parentheses on this first row. So I literally just took that parentheses and dropped them for the first 2 parentheses. For this parentheses, though, I had to distribute that negative. So that's why the 2 numbers here are negative at the far end. Once I did that, I combined in my like terms. So focus and stay with me. The 5th power, end of the 5th power is right here. Nothing changed. There was nothing else to combine it with. The next thing I combined were the ends. End of the 4th. Both of these end of the 4ths, they are right here. The reason why I made those with a denominator of 6 is because I needed to add them. So I just multiplied the numerator and denominator here by 2, and I multiplied the numerator and denominator here by 3. So that's how I got, respectively, 8 over 6 and 3 over 6. The next part that I did was I combined it. See if I can find another color to highlight with. Let's do just the ends, just the single ends. So positive 1/2, positive 3 over 2. That's how I got 4/2, because literally you can just add those. They're both over 2 already, so I could just add those to get 4 over 2. And then the last thing that I did is I combined the constants, which were 3, 2/3, and -2, which I combined it here. 9 over 3 is going to reduce to 3. 2 over 3 is the same as 2 over 3 here. And -6 over 3 reduces to 2, which is there. So I combined everything. Once I did that, I just simplified and I tried to see if any numbers would reduce. So for the first one, I just recopied 3 over 2 end of the 5th. -8 minus 3 is going to give you -11 over 6 end of the 4th. 4 over 2 reduces to 2. And when you combine all of these, 9 plus 2 is 11. 11 minus 6 will give you 5. So this guy here, which I'm going to highlight in hot pink, is my answer. So honestly, all of the function operations and function notation, polynomial operations, we've done that on this page. So the rest of this page, along with the next page, along with the page after, which is extra practice if you have this, these are all extra practice questions that I want you to try. This is going to help you with getting ready for your tests and quizzes, especially questions that have fractions. If you have any further questions on this concept, guys, make sure you let me know as soon as possible.